Fatigue has long been an issue among healthcare workers, being associated with increased medical errors, decreased task efficiency, and lower quality of patient care. Due to the prevalence of shift work and the biological strain of operating against one's circadian clock, medical professionals are at a high risk for fatigue. Similarly, due to the dual pressure placed on them from their coursework and their responsibilities as in-training clinicians, medical students may be especially at risk for workplace fatigue. Therefore, in order to minimize accidental harm and optimize patient care, it is necessary to develop accessible, non-invasive, and valid measures of fatigue. Fatigue is often measured via self-report questionnaires. However, this approach is limited as fatigue is a multidimensional experience and such measures are inherently subjective. Therefore, it is prudent to develop an objective measure of fatigue that can be cross-validated with subjective data. Electroencephalography, EEG, is a widely used objective measure of cognitive activity and fatigue. Observance of low-frequency theta wave activity, which is between 3 and 7 Hz, and of alpha wave activity, which is between 8 and 12 Hz, predicts greater fatigue, while observance of beta wave activity, which is between 15 to 30 Hz, indicates greater alertness and less fatigue. 37 first and second year medical students were recruited from the University of South Carolina School of Medicine, Greenville, to participate in this experiment. Participants completed 2 consecutive data collection sessions, approximately 12 hours apart, where their responses to 2 subjective fatigue measures, the Epworth Sleepiness Scale, which measures habitual sleepiness, and the Karolinska Alertness Scale, which measures state sleepiness, were recorded. To obtain a comparative objective measure of fatigue, participants' brainwaves were also recorded continuously using a live AMP 32-channel EEG cap for 5 minutes after completion of a memory task. As expected, results indicated that higher theta wave activity was associated with higher state sleepiness scores on the Karolinska Alertness Scale and were associated with not feeling refreshed. Additionally, higher alpha activity correlated with higher habitual sleepiness scores on the Epworth Sleepiness Scale and with lower scores on the memory task. Our findings suggest that EEG may be an effective tool to objectively assess sleepiness and cognitive processing, which adjacently measure fatigue, and therefore may provide greater insight into the fatigue state than subjective questionnaires alone.